Hey
Hey guys.
Martin, hey Souvik.
Hi guys.
Hey, nice to see you here. Okay, so now the active part of this conversation starts. I mean, the live interaction with people, and yeah, everyone says, "Whoa, drinking coffee fast," and so on. Brilliant. Okay, we've got some questions, and we will start discussing them very soon. And also, I would like to encourage people to send more and more their questions right now. However, assuming that the format of the Q&A panel is a little bit different from individual Q&A sessions. Why so? During the individual Q&A sessions, mostly questions are addressed directly to a specific person in a specific case in order to discuss it a little bit different and a little bit deeper, I would say so. In our case, well, we have experts from different area, but still on the same huge, let's say, topic, we have a possibility also to discuss some questions from different points of view. So, as a very first question to you guys, just in order to warm up this session. So, you've been talking, as overall, just to refresh, you've been talking about integrating React into legacy projects. That was Martin Chaov. Super React tools to boost developers' productivity. That was Souvik. And manage your React app better with Mobax. That was Tarun. So we can see that from one, like we are talking about boosting and integrating mostly. Could you just quickly maybe discuss between all of you what is the biggest difference between React ecosystem nowadays, the modern React ecosystem, and the one that becomes already legacy, but you can still find it in a lot of working and existing software and projects? Raise your hand or a finger. Okay. First place in the queue. If you want to book a place in the queue for the same question, just raise second, two fingers or three fingers, depending on the place. It's just a quick way to moderate things. Okay. I can see
Yeah.
Martin has booked the third place. Cool. We start with Souvik.
Sure. Yeah. So one thing that I definitely see is the shift from class-based components to function-based. So in fact, when class were introduced into JavaScript through ES6, it was not a very welcome thing from a lot of developers who were tuned to dynamic way of programming. In fact, like, we liked the way JavaScript was dynamic and prototypical and functional. And the classical approach was made more to accommodate Java or C# developers into JavaScript, so that they can have a lesser learning curve. But a lot of things doesn't really fall into picture, especially with tree shaking and like we do definitely face a lot of problems with classes, especially in JavaScript. So with React hooks, in fact, supporting totally on the functional components. So I see anybody who is creating new React components should be aware of this and try to create functional components rather than classes, I would say.
Okay, thank you. Tarun, keep going.
Since actually when I started React in 2017 back, at that time, like Souvik mentioned, there was class based. We moved to functional based. That basically changed the mindset of the folks who are coming to React. And second big change is, like, when React was launched, it was just, I would say, replacement of jQuery. Like, it's a view part only where we play with the things, and we have that kind of privilege to create your own different framework rather than in Ember or React Angular. We have ready-made framework. But at that time, I think the folks who created React, they didn't take state management that much preference. That's why we have to accommodate Redux separately. But right now, after 16.4 or in the coming days, now they are serious about state management as well. what they did is now they included the reconcile. If I spell it correctly, reconcile library, which Facebook created. And second is they have created this hooks and the context API by which they are moving towards like we should have all these things inside, which every developer that needs to do that kind of thing. And the third is error boundaries that we have included in React. Like we already so in the old versions of React, whenever there is error come from backend, simply you see a blank page, white screen of death. You have to go to console and understand that. And the error handling mechanism was not so mature, but right now we have error boundaries where you can define your own way of handling different errors in React. So based on that, we get more concise error in the screen than we get. So this is the second thing. So yeah, two inputs from my side. One is the state management thing, that is these folks are taking it very aggressively, or I was very passionately, like they are trying to integrate inside the React ecosystem already. And second is the error boundaries or the hooks part that is creating. Yeah, functional part that is already mentioned by Souvik, that was also important part, but these two things which I think important.
Thank you so much. Martin, can you summarize that?
So yeah, but I also add stuff because this way I
Yeah,
feel
yeah,
to be
sure.
last because I can change everything, right? So yeah, the tools are improving. So definitely the tools are improving. The community is improving. Something else that's happening is that TypeScript supports more functional oriented types that allow you to do all those nice functional concepts. But something else is happening. What I see is that people who are writing bad object oriented code are now writing bad functional code. So the code is not improving on general. That's what I see, you know. So we were writing bad object orientation. Oh, the fault is not with us. Object orientation is bad. So now we are writing bad functional programming, bad functional code. So the fault is still not with us, right? Now the tools are the problem, or something else is the problem. I see a huge misunderstanding about the concept of why something is called functional. Why are we calling something immutable? Why are we saying that the function should be referentially transparent? What does it mean for the way you develop software? So I see various different levels of misconceptions that are popping up, and people don't actually spend enough time to understand what those concepts mean, because they have deeper meaning. Why? So you're saying the function should be pure. Okay, why? Well, it should not have side effects. Yeah, I agree with you, but why? Why are we doing this? Where are we doing this? Okay, let's think about it. So printing a document is a side effect. Do you need a program that cannot print documents? Well, that's a lousy program. Clicking in the browser, hitting enter and getting Google, this is a side effect. So obviously you need side effects. It's important to understand where you need side effects. And something that I see is that people don't spend enough time into actually understanding their programs and what they're trying to achieve and how to isolate dirty logic from pure logic. And you know, there is this onion architecture with pure functional core and dirty outside with classes and so on. Something else that is missing from the conversation is that the class is a very, very powerful metaphor. The class, with one word, can explain a lot. A function can be much more generic. And when you have such kind of abstraction, some of the meaning is lost. And when you want to translate ideas to people, you need to have a good, concise language to do so. So classes are actually not so bad. They can be very, very powerful metaphors. So the problem with object orientation is actually inheritance. It's not classes, right? So function that is creating an object, it's a constructor function, okay? Let's be realistic. Function returning object, that's a constructor. So the class is just a different way, different syntax to specify constructor function and object with methods. So there is nothing inherently wrong with classes. The problem is with inheritance and the way taxonomies are structured inside your software.
Okay, I understand that at some moment I've probably lost because I'm not a developer and some things are not that much clear to me. But thanks, and I can see that your feedback is actually getting feedback from people, if we can say so. Now let's move to the next question, which is, if we have hooks, then why we still depend on Redux and Mobax? Is it a good question? Right. You would like to go.
Yeah.
Guys, you can still book
So
book next answer.
it's one simple answer. It's abstraction. So you as a developer, as an implementer, should not be thinking only in terms of hooks or only in terms of Redux or Mobix. You should be thinking in terms of what your program needs to do. And Mobix internally can manage state with hooks, and that's fine, right? State management is something that you should not be managing directly. It's something that you should be abstracting away, structuring in a reusable, nice way, like with Mobix. And hooks are allowing you to write your own code that is managing state, which is very, very nice.
Mm-hmm.
But a Mobix with adapter that uses hooks and changes React behavior is the same Mobix code that you can use without React, that you can use with Vue or with Angular, with a different adapter. Okay, so we're talking about reusability. So Mobix is adding a layer of abstraction, which is giving you code reuse between different presentational layers, which can also work on the backend because there is nothing React specific about Mobix. So
Okay.
that's very powerful. Abstraction is very, very good.
Thank you. And in that case, I have a good question for all of you guys, and I would be happy if you discuss it a little bit more. So here's my question. Imagine that you have a case, and I'm pretty much sure you already have dealt with it. You have a case when you have to migrate, like a web service. Okay, like let's say you have a backend, and that backend works fine, but then you need to upgrade the front end for a few different reasons. Would it be, let's say, migrate from React to Angular or vice versa, or just you need to do a full upgrade and do that on the go? So I realized that using a state manager is actually a good practice for that. Okay, or maybe including even more services. I mean, not only the web one, but even more ones that rely on the same that they rely on the same states, but then actually provide you more data in a different way. Am I right supposing that you can also connect a mobile application, let's say, to the same backend if you already have a state management? It's just a question starting here. So main question is about how we can use a state manager as a middleware for any kind of migration or upgrade. Souvik, go ahead.
Yeah. So state management, although there are ways to have like generic state management for your different frameworks, I'll probably not go for it. Like I work on few Angular or React projects, and if I have to, let's say, totally replace an Angular project with React, I would probably not think of taking out the state management part of it and use it in React, because a lot of these frameworks they are pretty much tightly coupled, you can say, to the way data is managed. Like for example, React hooks that we have is designed pretty much keeping React in mind. And like if I'm using NGRX in Angular, that's pretty much for Angular. Although there are parallels for them in all the other frameworks. For example, Mobix will be there. You can use it for either of these, or even NGRX has a React version of it. But when I'm working on one particular project, I would probably concentrate on just how to do state management best invest in that particular framework, because fine tuning is important there. Like if I am achieving reusability at the cost of a slower interaction or a bad UX, probably that is something that I would probably not go for. In fact, even when we were jumping from Angular 1.x to 2.x, although they were the same named framework, but like two different implementations, a lot of advice was to actually start writing it from scratch rather than trying to fit in things and go island hopping one by one into from one framework to another. That's my take. Yeah.
Thank you. Would you like to add something else to that? Okay, I have next question, which is, can you elaborate more on inheritance problem part of classes? I guess that's to Martin.
Yeah, I guess so as well. So the problem with inheritance is that it's very brittle. So it's very hard to come with a taxonomy. Taxonomy is the relationship between types. It's very hard to come up with a taxonomy that can be easy to extend. The problem is that when you start doing object orientation with inheritance in mind, inheritance as a mechanism for code reuse, you're generally looking at the current state of the program and trying to make up all the relationship between all the objects, and have some limited view of the future where you try to actually think about how this is going to evolve and set up some places where you can extend. The problem is that in real life, it doesn't happen like this. When the application starts evolving, all those relationships between the objects starts making problems. And so when you have, think about it this way. So if you have one level of inheritance, it's probably fine. So this is where you can do some kind of integration. This is where you do a layer of integration between two different applications. This is like one level of inheritance. It's okay, and it should be inverted, obviously. You should be injecting the dependency. But then if you have 7 or 6 layers of inheritance, now, first of all, it's very easy to come to a situation where you have circular objects. So objects that need to inherit something that they have another parent that is inheriting it, and so on and so on. This is one thing. Another thing is that when you have deeper layer of inheritance, the impact of any change to the code base becomes very, very big. So it's very easy to get to a place, it's called the God class. So that's the class that everybody is inheriting. So any change to this class may break the entire program in undefined ways. That's a problem. So applications are becoming more unstable and becoming less predictable. So when you tell me, okay, I want you to add one button, and I'm like, oh my God, I'm inheriting 7 classes here, and this service is actually inheriting another 16 classes, and this is coming with dependency injection, but it's actually an interface which is extending 5 other interfaces. Where do I need to add the button? I don't know, and I'll give you a stupid estimation, like 5 weeks. And the product owner is going to say, but I just want you to add one button next to the other button. Put it next to the other button, right? But it's not so easy to make it in code. And this is the inherited complexity that comes from this kind of thinking. So this is the problem with inheritance. It becomes more and more brittle and couples your code.
Okay, cool, thank you. I like your way of philosophic answers, and I can see Souvik is also wants to say something. Here you go.
Sure. Yeah, thanks. So just to add to Martin's point, the way I look at the problems of inheritance is with the maintainability of the code. So we always have this choice between using inheritance or using composability. Basically, what we are ultimately trying to achieve is reusability, right? Like, let's say if I create a person class, I don't want to create write the same code again and again when I want to define a person. Let's say tomorrow, if I want to create a person who can walk, I don't want to create the person class from scratch, but I would, I have the option of either using inheritance, like person who walks, like one class. That's like an inheritance of getting everything from person and then adding to it. Or I can do some kind of a composability where I can have the person class and add behaviors of walking into it. The problem with inheritance here is that, let's say if I have a person who can walk, tomorrow if I want a person who can swim, do I inherit from the person or the person who can walk? Like, that's a problem. Like, because a person would be able to walk as well as swim. So in that case, I will think that, okay, let's inherit from the person who can walk and make it another class as, like, a person who can walk and swim. But then things starts getting complicated here. Now, if you want to have a person who can talk, like, where do you put that thing in there? So a composability makes it much more easier. Like, you just define all these behaviors separately: walk, talk, and swim, and you just have the person class, and you add things that you really want. The same thing is there for UI as well. If you have a component, instead of trying to inherit from it, you just start adding smaller components within it to make it a bigger thing. So ultimately, we achieve the same reusability, but with a more maintainable code, if we go for composability instead of inheritance.
Okay, so
I want to add something.
Sure.
It's okay.
Go ahead.
Everything that Souvik said is right. It's important to stress that you can compose classes. Okay, you can compose objects, you can compose functions, you can compose classes, you can compose interfaces. So the problem is with inheriting classes, not with implementing class. You can implement class and you can compose the classes, and it's fine, it's composition. The problem is when you're inheriting the classes. So this is where this complexity is coming from.
Yeah, of course. So it's actually I was actually talking about the inheritance of the classes itself, like not function versus class, but about, like, let's see, if I have to keep inheriting the classes, we definitely reach a point where it becomes very difficult to figure out where to inherit from. And also one major problem that I have seen, I just recalled, was that sometimes when our base class has been inherited so many times and used at so many places, now that code becomes very fragile and very difficult to maintain, because a little bit of change I do in that kind of flows down into my entire inheritance hierarchy. So instead of that, if I had just used composability, then it becomes much more easier to just take it out and replace it with something else.
Very well. Okay, thank you. I've got 2 more questions and we've got 10 minutes. I hope we can discuss at least these 2 questions and maybe go a little bit further. One of the question becoming quite popular one is, okay, so some people are asking if there is any advantage of using TypeScript in React, and is there any sense of that actually? Who would like to go? Okay, yeah, okay, Tarun, you can.
Souvik, you can add first, then I'll add.
No. Actually, I'm sorry. I've been picking up my hands too much. Like, please go ahead, Tarun. I'll go after you.
Okay. So just to answer that question, so it's I didn't find any advantages of using TypeScript in React. Like, TypeScript was using when we do not have ES6 and ES7. So we have all the features that were existing in TypeScript that is now in ES6. React is already using that, so I don't find any much reasons. So you can simply use classes, hooks, use effects, and everything we have. That is very simple and straightforward. We don't need an extra library to do that. So my suggestion is no, I don't use.
Sorry, I was muted. Okay, thank you, Tarun. And let's put Souvik there. And I see Martin booked the 3rd place again.
Yeah, so I think this question came from one of my slides where I recommended to use TypeScript in React as well. So Tarun, definitely I agree with you. So like most of the things which were in TypeScript is available in ES6 anyways today. But if you look at this trend, like few years back, these things were part of TypeScript and then JavaScript adopted it. So it's always like that between a community and a standard. The community is always ahead and reinventing things, and that when it gets assimilated, like when a lot of people adopt it, that becomes a part of the standard. So TypeScript is one such community effort wherein people are coming up with a lot of new ideas of doing things, and once there is a lot of adaptation to that, it becomes a part of the standard. So likewise, TypeScript always is kind of a superset of the JavaScript standard or the ECMA standard. So whatever was there yesterday is today's standard in ES6. Similarly, whatever is there in TypeScript today, if those are useful, they will become part of the standard tomorrow. If those are not useful, they will not become part of the standard tomorrow. So yeah, so as far as adding another library is concerned, it's not really another library because your code actually gets compiled back to JavaScript and then runs. And all depending upon which build tool that you use, whether you are using Webpack or Rollup or whatever, they will have different degree of translating that, like transpiling that code to a better JavaScript code. Yeah, so let's say if you have decided that there is absolutely nothing that you need out of what is provided by ECMAScript, then probably that's a better approach to go, because you get streamlined, like absolutely lesser number of piece of code to work on. But I will still go with TypeScript, especially for the type checking, which is still not so much as part of JavaScript yet. Like, you don't want to use prop types or things like that to do type checking. The way TypeScript can catch these errors, and today, especially with so much of support in our IDE tools to catch errors in TypeScript. Let's say if I don't define an output type for my method, it at least gives me a warning that, why don't you define it? And if I define the type, and in some instance, if I'm returning Boolean and it's taking a string, it will give me an error. So that's kind of, a little bit of an ahead of time. It gives me some kind of an indication of the type of errors that I might face, because JavaScript by itself will never creep about it when it actually runs on the browser. But during my coding time, I can get some kind of an indication. So that way, I would probably still want to stick with TypeScript. Few disadvantages, though, is that a lot of libraries, they do not support TypeScript right out of the box, because they have to define the types as well. And sometimes there are problems. Like the earlier versions of Redux was not really so much compatible with TypeScript. Okay. But I think it has been adopted quite a lot with all major frameworks. Like even Angular was always on TypeScript. Vue has adopted it now. And even React is taking it up now. So probably I will go for it.
Okay, thank you.
One point I would. So Souvik, you rightly said, like, TypeScript is ahead. Community is always ahead rather than the language. I totally agree. But yes, if this is your case, like you want to have that kind of strict type checking, and you don't want to use prop types and other stuff, and if you want to use the advanced features in your application that require these kind of features, yes, in that case I agree. In that case, you can use TypeScript. But if you're creating a general application and using React for the first time, and as a beginner, in that case, you have to think about it.
Thank you. Martin, your turn.
So, in addition to what the guys said, with TypeScript, you're getting one very, very important advantage: interfaces. As I said during my talk, you can publish a package, npm package, with just interfaces. This allows you to do inversion of control. This allows you much more granular control on the behavior of the code, on subscribing to contracts. All the nice things: low coupling, high cohesion, solid principles, yada yada yada. All those things you can do very, very easy with TypeScript. Also, let's think about onboarding a new guy. Yeah, you're very good. You know all the code that you wrote. Good. New guy, no IntelliSense. What do you do? So the interface, the IntelliSense that the IDE is going to provide for you based on the types is very, very nice feature. And this is why a lot of strictly typed languages, and not only F#, for example, has a dynamic type system. It's still very, very good type system. JavaScript does not provide very, very good IntelliSense, and TypeScript is helping here. And this is just one of many advantages, because today you're writing ES7, 17, 25, it doesn't matter. Tomorrow, you will need to rewrite the code. And with TypeScript, I'm going to change the configuration and recompile the code. And I will get latest standard, always. So this is also a very, very big advantage. But when you're managing many teams, many projects, interoperability between them, TypeScript is becoming invaluable tool. And it's actually helping you achieve your company goal, your business.
Thank you. Thank you so much. We have 3 more minutes, and it brings us to the last question, or we would like to summarize all of these. So you've been talking about a lot of different approaches to the technology itself, to different tools, and so on. So probably a really logical question would be a few recommendations, maybe up to a minute, just a few recommendations from each one of you for some, let's say, technological setup for the ones who are just joining React development as junior developers. So what is your must-have which can balance between exploring features, achieving results, but still, how to say, still not so much complicated in learning curve. So balance between all of these three things. Who's ready to go ahead? Okay, Tarun, you go.
Okay. So the key of learning Java, learning React for the first time is the few basics fundamentals of JavaScript. If you learn like how spread operator work, if you learn how some of the basic things like how arrow function is different from other functions, how classes work under the hood. Like when you write a class, it's a syntactic sugar which actually a prototypal inheritance. If you understand these 4 5 of basic concepts of JavaScript, don't go so deeper. Just only relevant 5 to 7 topics which I can remember: arrow functions, prototypal inheritance, string immutability, how triple like spread operator works. These are the few pointers. If you clarify all the points, it will give you a base foundation, and that will make your React learning curve more easier.
Brilliant, thank you. Who wants to share next?
All right, I'll take it. Okay. Souvik, please.
Souvik?
No, please go ahead. Yeah.
Souvik is the champ.
No. So, actually, this reminded me of a very recent tweet from Dan Abramov, where he gave a very, like something against a very popular opinion, where he said that you don't need to learn JavaScript for React. When Tarun was talking about it, I just recall that. But yeah, I totally agree with what Tarun is saying. I had I've seen one thing here is that whenever you want to learn something in deep, you have to dedicate a lot of your time and focus into learning things properly. And JavaScript and React, both of them, they definitely need some special attention, because if you're especially coming from Java or C# or such OOPS background, then you'll definitely have to unlearn certain things and relearn things. But what happens is when you are very new to something, these kind of things can really bog you down very easily. Like, when you have to read so much of JavaScript, like, how the arrow function works, or how the this operator works in JavaScript and things like that, how the variable hosting is happening. They are kind of technical details, and you don't want to really get into that. You really want to, create your application and see it working. And that's something that gives you that kick to, move forward ahead. So a lot of times what I really recommend a lot of my students is, just use create React app, the basic tool which has been given by the React community. Create an application, just get it running, and see the first web page running on your browser. That's a very big, boost for somebody who is just starting, because they see something really working. And try to use like the very industry standards which everybody else is using, irrespective of whether it is good or bad, or having all the features. Don't forget about it. Yeah. For example, just go for VS Code, like because that is something which has been used by everybody else. And don't worry about the state management and things like that at the very initial things. Just try to get things, just go to the level where you can see things working, and then one by one start digging deeper into the details of JavaScript, the details of React hooks and state management and things like that. That will get you more interested into things.
Okay, thank you. Last words from Martin.
So I kind of agree with Souvik, so I'll just add to him. Use TypeScript and use linting, and this is going to help you a great deal, just in terms of typing. So every time you need to do something in React, TypeScript is going to give you detailed IntelliSense and documentation inside of the Visual Studio Code. You don't need to open the documentation, search, find, read, then go back, then, okay, I forgot what is the third parameter of this function. So go back to the documentation, and so on and so on and so on. So TypeScript and linting, you can use ESLint, for example, or something. So these tools can actually help you boost your productivity and abstract away the things like keeping in memory signature functions, keeping in memory pieces of documentation, and so on and so on. And I find, for me, myself specifically, that having this integrated into the development environment helps me a lot. So I would always advise people to set up TypeScript and linter together.
Okay. Thank you. We are out of time now, so it was an amazing panel discussion. I can see that there are still many questions that remained unanswered, and probably we're going to need another day for that, which we don't have. So at this moment, I would like to thank all of these amazing speakers, Martin Chaov, Tarun Nagpal,
Yeah.
and Souvik Basu.
Yeah.
Thank you.
Thank you so much for having us here, Charlie. And thanks, Martin and Tarun. It was nice talking to you both.
Yes. Thanks.
Thank you,
guys.
guys.
Thank you.
Thanks.
Jason.
Bye.
Bye.
Right, I would just like to remind you that this is the React Global Online Summit powered by Giggle. It's a huge event that's running 24 hours all over the globe. We have a lot of amazing speakers, and all our conversations are divided into two tracks, the junior and the senior one. Here is the junior track. Right now, my shift is over. I'm passing this service of moderation, this amazing conference, to our next moderator that will join just in a few minutes. So thank you all for your amazing questions, for being so active. Actually, I've got really tired to try to read all your comments and keep them in one place, collect your questions, ask people, and so on. So thank you, and see you soon.